Same thing, same thiamides we have synthesized.
प्रवीण माउस जवळ ठेव तुझ्या. क्लिक कर त्याच्यावर.
So these are some literature how people have synthesized thiamides. See aldehyde, morphine, sulfur. This is the PSOH. This is temperature. You can have some compounds. Aldehyde secondary amide using sulfur, NMP as a solvent using microwave. You can synthesize thiamide. So these are the literature. Yes. From carboxylic acid, from alpha beta unsaturated carboxylic acid, we can synthesize thiamide. In organic matter also, from acetylene, they have synthesized thiamide. From disulfide, using iodine as a catalyst, DMSO as a solvent, they have synthesized thiamide. So these are the literature references where these people have synthesized thiamide. Now the interesting story is this. Again, these secondary amides are there, aldehyde. Using this, they have synthesized thiamide. It is reported in chemistry select. These are the good journals. Our group also reported the same synthesis using beta-cyclodextrin as a supramolecular catalyst in water at 100 degrees Celsius. Yes. So, why I have shown all this? You can change catalyst. You can change solvents, you can change the temperature for particular reaction so that you can develop a new synthetic method. Yes, for the thiamides. So this is that beta-cyclodextrin we have used, that is non-toxic catalyst, water as a green solvent, metal-free, oxidant-free, and all these 22 compounds we have synthesized using pyridine, piperidine, and morphine. This is another synthetic method we have developed. Yes, considering the literature, what people have did. Then think on it, what is remaining to do, and in that way we can work. Lastly, we have developed again in this work new method. See, Virginov kind of reaction never has been reported at room temperature in the literature. And for the first time, we have reported it at room temperature. So how this thing happens? All people have did it using aromatic aldehyde. These are the secondary amines, and this is the sulfur powder, which is in the form of acid. Yes. So just take the aldehyde 1 equivalent, take the sulfur powder 4 equivalent, and secondary amine double. Yes, secondary amide double. Suppose you have take 2 millimole of this, then you have to take 8 millimole of sulfur and 4 millimole of secondary amide. So just stir it in a DMSO solvent for 6 to 16 hours. For every reaction, completion time is different. You have to monitor it with the help of ELC. Yes. So at room temperature, by optimizing the ratio of these, we have synthesized 27 thiamide derivatives. Nothing, not much costly chemicals are there. No glasswares much. Take one only round bottom class is needed. DMSO is available, aldehydes are available, and you can develop new synthetic methodologies. So this is the simplest way you can decide. Of course, one drawback, though it is published in a good journal, tetrahedron, still it have a one drawback. Can anybody say what is that drawback? Any student? It is very good method reported in good journals. Still, some limitations are there.
More time. Too much time. In presence of heating, it takes 3 hours.
Yes, we have optimized it at room temperature, and at 120 degrees centigrade reaction time is lower. But here for 120 degrees centigrade the ratio is 1:4. So this is the new synthetic method we have decided. Yes. What are the limitations of this? We should clearly see what are the limitations and what is the future scope there. Yes. As far as my knowledge or student knowledge, they have tried their best. Still there is a scope to one. So what are that scopes in this reaction? The answer is in front of you. This is the beauty of organic chemistry or chemistry. Once you write it on the board, the answer is on the board. Just there is a need to make the question mark. Yes, ask the question. Just one person have asked. So reaction time is higher. Can we decrease the reaction time so that you can develop new synthetic methodology? So you have to raise the question in your mind, and this is the start of your research. If we are just followers of the others, then the problems will be there. We are graduate or postgraduate students, teachers, researchers. Yes, we should learn to ask the questions. So another question is there, DMSO. I am just giving you the hint. DMSO is also not a green solvent. So can we replace DMSO? So another synthetic method can get developed. Can you raise another question? There is a scope. तर आपल्या मनात पहिल्यांदा प्रश्न तयार झाला म्हणजे हे असं का, हे असं का नाही, हे असं करू शकतो का? So once question get arise, try to solve it. It gets solved by experimentation. Yes. That's why Newton is the person who is saying, observing that mango or apple something is falling down. Everyone is observing the thing. But Newton is the person, or thousands of persons are there who have raised the question. Why it is falling down? Among that 1,000, 10 students may be there or 10 people are there who are trying to solve that. Just asking the question is not the start of research. You have to try to efforts. आपको प्रयास करने पड़ेंगे तभी उसका जवाब मिलेगा. Yes. So is there another question? I will tell you. See, there is a one more scope. Sulfur is 4 times, 4 equivalent. So it is much more than. So can we reduce it? Can we replace it? Can we change the aldehydes? Lot of there. So in this way, you can develop good synthetic methodology, novel synthetic methodology. Yes. So see, optimization of solvent is carried out. How this to develop this? You can optimize the solvent. If in your solvents are there, try to perform the reaction with that solvents or catalysts. What happened when I perform the reaction in DMSO with this mole ratio of aldehyde, sulfur and secondary amine? At this ratio 1:4, 4:2, see, 56-hour reaction time is 78%. Here, if I will increase the ratio of secondary amine from 1 to 1.5, reaction time is reduced and yield is increased. Again, what these two parameters suggest, try to increase the mole of secondary amine. So when it is double, reaction time is lowest with highest. Can only the DMSO is the solvent? Try for another solvent. So people have tried for another solvents, and these are the results. And among the table, you can choose the best one. Among the table, you can choose the best one. So only room temperature is the option? No, you can perform heating so that what the question asks, can we reduce the time? So let us heat it. What will happen? So same thing is done. We have heated it at 100 degree. See the result. Reaction time and increase the temperature 120. 24 hour 64%. Just there is an increase. The mole ratio is 1:2:1. But when this mole ratio is 1:3:1, reaction time is 3 hours with 85%. Just I increase the sulfur. When it is again increased 1:4:1, at 120 reaction time is lowest 0.5 hours with 93% of heat. So in this way you can optimize the temperature, you can check the progress of reaction with TLC. So all these things doesn't require sophisticated laboratories and all that chemicals. Yes, you can try for your project and all these things. Yes. So in this way we have optimized other solvents also. Yes. And this is the simple method we have developed. Take a round of bottom flask, add it to aromatic aldehyde, morphine or piperidine or pyridine, elemental sulfur powder, and then reaction mixture was continuously stirred at room temperature. Stir it. You will progress of reaction was monitored by TLC, and after completion you can pour it in ice water, stir it, filter it, wash it, dry it, and purify it using column to remove unreacted sulfur. We are using excess of sulfur, so we have to remove it by passing to column. And finally, pure product is obtained by passing ethyl acetate as an element. So this is the simple procedure get developed, but after too many experimentation and too many failures atoms are there. Yes. So this process get developed, which will get good publication, or you may get good jobs in the industries also, or you will get such method habit to develop such method. So at 120 the same thing is there, just reaction time is low. Then compare it what other people have done. If your results are good, definitely you will get good publication, patent, or you can give the process to the industries also. Yes. As a chemist, we can develop a mechanism for that. And mechanism is basically from our knowledge. We know lone pair of nitrogen attacks the electron deficient carbon. Same lone pair can attack on acid. So this intermediate will form. Again, by removal of OH, this imine is formed, and this S minus attacks at this imine carbon. You will get this hydrogen shift. You will get hydrogen. This is possible mechanism of that reaction. So lot of derivatives we have synthesized at room temperature at 120 degree centigrade temperature. So these are the different aldehydes we have used. Aromatic aldehydes, aliphatic aldehydes. So then another question is that once you develop the process, can it goes to industry? For industry, the quantity is more. It is not 1 millimole, 10 millimole like that. It will be kg, ton, kg, quintal or tons. This depends on the requirement. So try to increase the starting count. If you have started with 1 millimole, can we take 100 millimole in the flask? Carefully stir it, observe the reaction, remove the side effect. Just we have observed exothermic reaction where we have added benzaldehyde and morphine. In small scale it will not observe, but when you are taking kilos and tons as a starting compound, this thing should be very carefully checked. So in this way you can develop the processes. Yes. Then what to do as an organic chemist? You have to do the characterization. We can't observe the structure of any compound. with naked eye. So we have to perform UV, IR, H1 NMR, C13 NMR, mass. If they are new compounds, then you have to go for, this is C13 NMR. C13 NMR, these are the NMRs. So in this way you have to characterize it. How to characterize? We don't have that facility. Yes, you can go for some DST site. You can send the sample to say Chandigarh, see the names. Punjab University, Chandigarh, same central instrumentation facility is there. So with minimum charges they are providing the characterization of this. So we can do it. If you wish to do something, you can do it. Lot of technologies are there. Facebook is there, Twitter is there, Gmail is there, WhatsApp is there. If you are honest to approach certain persons, definitely they will help you. Yes. So these are some conclusions, these are some references. These are some references we have used for the research. Yes. This is the graphical abstract which gets accepted on the journal of tetrahedron. See, whatever the limited facility you have, if you do something good, that may be equivalent to very great publication. So under given circumstances, what we can do, that is very important. And whether we are doing that or not, that is very important. So try to do something. Even I do it, other people have also did it. See, same one, it is just paper in the current month also, in the Journal of Organic Chemistry. Aldehyde, sulfur, secondary amine, same room temperature. What that people have did it, 40% weight of amine in water they have used and they have performed. Same one. We are also working on that. But other people are also working with the same idea. So they have used water and THF as a solvent to carry out this reaction. Yes. So this is recent paper in the month of February, I think. In a very reputed journal, KOC. As an organic chemist, we wish to publish the paper in this. So a lot of synthetic methodology you can design. Yes. So see, don't bother about the structures and all that. Chemistry is very simple. This is silica sulfuric acid and this is nitric acid. The role of nitric acid is nitrating agent. Just nitric acid is supported on the silica. Yes. So it becomes solid nitrating agent, and that is used to nitrate this compound. After nitration, this H molecule is there, which is called TEX. So it is a very explosive, low sensitive molecule. So whether we are the first person to design this reaction? No. Lot of scientists already have worked on it. Yes. So the interest is that someone have reported the synthesis up to 58%, and we have reported this synthesis just by increasing the yield by 7%. How much? 7%. So it is an explosive, very important compound. Cost of the synthesis will save, so it makes good publications. You can patent the processes also. Cyclodextrin nitrate ester and H2SO4. It can act as a nitrating agent to this compound. So this is another novel protocol we have developed for NTO molecule. This is NTO molecule. It gets nitrated with cyclodextrin nitrate ester and H2SO4. This is the novel nitrating agent. You will not see this combination in the literature. Yes. So those who want to do the research, they can collect all their work on one of the topic. So on one of the topic, if you collect lot of papers, you can write down book chapter or read it. COVID is there, no chance to work outside, so you can work at home also. Yes. So that's why I'm showing it. So but what is the need of this time? See, look at the nature. Nature is performing the reaction at room temperature, without catalyst, without temperature, without solvent. Our body is synthesizing the cholesterol very easily. If the cholesterol get increase in our body, there is a chance of heart attack. Yes. But have your body use higher temperature to synthesize cholesterol? Have your body use DMSO, ethanol, methanol like solvents? No. Have they used some catalyst? So this is the learning from nature. Nature is synthesizing lot of compounds at room temperature without using a catalyst, toxic solvents, temperature. Of course, there are catalysts in the nature synthesis. They are enzymes. Enzymes are the catalyst which carries out this reaction at low temperature. Yes. If the activation energy of the starting compound get decreased, you have seen the activation energy graph. If you bind the substrate with some enzyme, definitely activation energy get lower and reaction can be performed at low temperature. So carefully observe the H10O. Its molecular weight 130. The product is different. P3 shift. The molecular weight is same, carbon, hydrogen, oxygen atoms are same. So nothing waste is done. Not a hydrogen or oxygen get wasted. So such beautiful reaction, if you can design, definitely you may get another Nobel or some publications in the nature also. Yes. So try to save the atoms in the synthesis. So you should have good atom economic synthesis. Yes. If your atoms are saved, definitely it is atom economic synthesis. You may have one trials and aldol reaction. Still you can see number of papers on the aldol reaction. It is very older reaction. Yes, but enantiomer selectivity, diastereomers selectivity, that having the weightage. You can use cesium chloride as a catalyst. Lot of things are there. I am omitting this. Yes. So one of our BSc MSc students have developed this reaction. Always I am showing it. Just take aniline, carbon disulfide, water, and just keep it on the react faster. So on the roof, you can carry out the reaction within 6 to 12 hours. You will get beautiful product. So such type of reactions also you can design. Lot of things you can do. In this work we have used aliphatic amines. These amines are aliphatic. Same carbon disulfide, water. Just here on the roof reaction not completed, so we have provided stirring to it. But the beauty of this reaction is that non-isocyanate route we have developed. In other synthesis, these isocyanate derivatives are there. These isothiocyanates are get synthesized. In our case, these things are not generated directly. You are getting the product with this mechanism. Simple reaction, it is very simple. Doesn't need lot of chemicals and all that. All these things I am showing because you should get encouraged to do some work in the laboratory. Yes. And once interest get developed, definitely you can carry out lot of things. Yes. You can develop some molecules for solar cell applications also. Just synthesize the molecule, test this solar cell application. We don't have facility to do that. But you can synthesize some molecule, put it on the plate and send it to other people who are working on solar cell. They will perform all the characterization and you will get the results. So in this way, you can do some of the work. See, this is what I am saying, enzyme as a catalyst. We can use enzyme as a catalyst to carry out the synthesis. You can synthesize some of the molecule, you can carry out sensing purpose also. Yes. Dr. Kundan Titus is also working on this sensing of the molecules. You can sense the cations and anions with the help of UV fluorescence. So in one step we can synthesize the molecule and test it. Definitely we will do some good work. Here phosphate ions are get sense. Definitely after with the help of collaboration we have did it. Then the last question, what work we have done? This work is done by the students which are doing the PhD. So these are some students, all are made set qualified after joining the PhD. And these are the students who are working presently. Whatever first paper I have shown of this Arun guide. So definitely I have shown some interesting reactions to you. My motive is to encourage you for the research and to show you it is very simple. If you try, if you start to do something, it is simple. Initially we don't know all the things, now I know all the things, but still okay. Start of the research is always like that and then we can go ahead. So here I conclude my talk. I am particularly thankful to our Honorable Vice Chancellor, Professor B.L. Maheshwari sir, for permitting me to come here. I am very much get impressed. I am thankful to President of this Shiv Chhatrapati Shikshan Sanstha, Dr. Gopal Rao Patil sir, for developing this beautiful campus for all of the students. Yes. I am thankful to our principal. In the afternoon session I met them. So you got very good principal having lot of visions. So thanks to Dr. Madhav Gauhane sir. Thanks to Dr. Palke sir, who is the head of the department. I am thankful to Dr. Momin sir, Sulevar sir. They are continuously taking all the follow. Even in the midnight at 1:30 they are waiting for us. So I really thanks to them. I thank to our former colleague Dr. K.C. Titus sir, who have invited me to share my views on this dais. We collectively perform a lot of conferences in the interview. So I know he is doing a lot of good efforts for the students, for the researchers. Finally, I thank all the participants and organizing committee members. So see, if you have any question, you can ask. And finally, I conclude. Yes. Always remember this statement, which will give you a lot of stories. Albert Einstein is saying, education is not learning of fact. All the facts are there. I am teaching to you, this is not the education. So what is education? Training the mind to think. So if you have think something, you have learned. You have taken the education. So always think more around you. What are the things are there? Yes. Now the days have changed. You have to take skill education. You have to perform some group activities to learn the something. Yes. So thank you very much.
Now the session is open for discussion. Please ask the questions, any doubts?
Sir, sulfur is a very dangerous compound. So how do you separate that sulfur? Usually excess of sulfur in reaction, every reaction. So how do you
Sulfur is
separate
not
that?
dangerous actually.
It is smelling compound.
Ha.
And it
So
is,
it is very easy to separate. Just separate your product. Excess will go out. Just some of the sulfur is in your product. That's why we have to load it in the column, pass the solvents, so that first sulfur is coming out.
if we perform this separation at room temperature, so the smell of compound is spread everywhere.
No, nothing. That problem was not observed during the reaction. Yes. You try to use the reactions in sulfur. It doesn't create such problems. Just our task is to separate it from the react product. That's why we have to perform the chromatography.
Thank you, sir.
Anybody else?
Thank you, sir. Thanks for the motivation and support from your side, sir. We will definitely try our best to do so. Your words will surely be an inspiring way for us to live life in chemistry, constructively and find a way and solutions for the future. Thank you, sir, for the motivational lecture you delivered.
Sorry, sir, your formal income is left by mistake. Now I request the chairman